Now here the concept of null point. This is a gravitational force between two bodies is g into m1 m2 by r square. So what is concept or CAP? We call it concept, application and problem. This is combinedly, it may be a concept or an application or a problem. So what is it? Here m1 and m2, two bodies are there of masses m1 and m2. We have to place a mass m in between them. At this point, what is the force acting on it? The force should be zero. The gravitational force acting at this point should be zero. Now what is the distance? This distance we have to calculate. At what distance from the first body to this body, the gravitational force will become zero, which is called null point. Now to do this one, let us see. Here m1 and m2 is there. On this one force will be acting. If we want the net force on this one, net force this is the force direction 1. That is F1, and net force to calculate on this one, this is nothing but F2. F1 and F2 both are opposite in direction. So opposite in direction is net force equal to F1 minus F2 or F2 minus F1. And we don't know which is greater, F1 is greater or what, F2 is greater. Now net force should be 0. The condition is what? Net force at this point should be 0. So that is 0 equals to F1 minus F2 or F1 equals to F2. So this is what equation number 1 will make it. Now what is F1 and F2 will make it. What is F1? Now let us see. F1 equal to G into M1 M1 into M by x square. So if this total distance is what? D. So this remaining distance will become what? D minus x. So this will be D minus x. D minus x. Right? What? D minus x. Total distance is how much? D. Total distance is D. We are placing a body of mass M in the middle. Then this is at a distance of x. Remaining distance will become what? D minus x. Right? That's what I'm saying. It is not, you joined late now, so that is the problem here. So this may be at any point. It is not at the midpoint. It is not at the midpoint. What we are trying to calculate is, we are placing a body in between them. We are placing a body in between them. So when we are placing a body in between them, at this point the net force should be 0. I don't know what is that. If it is I, if I know that F is 0, right? So at midpoint I can write it as B by 2. That's all. There is no point of calculation. M1 and M2 both are different bodies, different masses. Now this is x and d minus x. Let us get a generalized equation for this x or what? D minus x. So now I can write F1 is G into M1 M by what? X square between the two forces, and F2 between these two, a force will be there. F2 equal to G into M2 M by D minus x whole square. Now to make this body, force is 0. So to make this force is 0, these two should be what? Equal. That is F1 should be equal to F2 because both are opposite in direction. Now if I substitute here, F1 that is G into M1 M by x square equals to G into M2 M by D minus x whole square. So G M will get cancelled. Then what is the next one? M2 by M1, just I cross multiply, rearranging the equation. M2, M1 is cross multiplied, I am taking this side, right? So D minus x whole square divided by x square. Or simply, if I remove this square, I can apply a root on that side. If I apply root here, D minus x by x is equals to under root of M2 by M1. Now what I do is individually I will divide D by x minus 1 equals to under root of M2 by M1, or D by x is equals to under root of M2 by M1 plus 1. So D by x. Now what is the value of x? Now I will write here. So now this is continuation. X is equals to D by under root of M2 by M1 plus 1 plus 1. So this is nothing but the distance. Now you ask that it will be center at what point if both masses are equal. Both masses are equal. Now let us try to substitute here. I am taking one example here. Example I take. Example. M1 is equals to 1 kg and M2 equals to 9 kgs and the distance is equals to 20 centimeters. The two bodies of M1 and M2 separated by certain distance. So this distance is nothing but 20 centimeters I am taking. M1 is equals to 1 kg and M2 is equals to 9 kgs. Then what is at what distance the null point will occurs? At what distance means if you substitute here, if I substitute x is equals to d by, so that is d is almost 20 centimeters divided by under root of 9 by 1 plus 1. The under root of 9 is how much? 3. 3 plus 1, 4. 4. 20 by 4. How much it is? 5. That means this is 5 centimeters. This is nothing but 15 centimeters. Right. If I take here, let us take this is also 9. M1 is equals to 9. M2 is equals to 9. Under root of 9 by 9 is 1. So that's nothing but by 2. So 20 by 2 is what? 10. So that means it will be only at center when M1 and M2 are equal. When it is not equal M1 and M2, so this is the formula to apply the gravitational force will be nullified at this point from a first body. If you want second body, subtract this distance, so that will be very fast. Is it clear? See here, this is three bodies, discrete particles. We call it discrete particles. Three particles are arranged at the three corners of an equilateral triangle. Equilateral triangle means here it will be what? 60 degrees. Of side A, and A. So in these three cases we will be discussing. Maximum of what? Three cases he will be asking. What are the three cases? Right. So in this one, whatever we are going to develop, concept is involved. So concept means what is the concept? Mathematical concept we have to involve. So that means here this I can say cap is nothing but concept plus. Then we have to apply. That concept we have to apply. So application. Concept is nothing but here application plus this is combining, transforming into a problem. So this name has given as what? Cap, right? So this is a cap. So cap is concept plus application plus what? Problem. Now in this one, case 1. What is case 1? Case 1. He may ask in this case 1 the force, gravitational force on any one of the corner. That is what case 1. Okay. We can pick at any points gravitational force. That already we did in the yesterday class, right? So gravitational force, let us take at this point. I want to calculate gravitational force at this point. Now let us take, I want what is the gravitation net force acting on this body. Then what we will do is, here let us take, this is the gravitational force between these two. First we will calculate. Or we can say that if I want net force like this, from this to this body, from here to this body, I want net force on this one. And one more force will be acting like this. On this one due to this one. So here let us take it that this is F and F1, this is F2. F1 and F2. F1 and F2. So F1 and F2 both are same, right? So which is nothing but F1 equals to F2 equals to G into M square by A square. Because both the masses are same, distances are what? Same. Now this is making an angle how much? 60 degrees. It's making an angle 60 degrees. Now if it is making a 60 degrees, two vectors, see very important concept here, when two vectors making an angle 60 degrees or any angle, we have to apply parallelogram of vector addition to calculate the resultant vector. So now this is nothing but a resultant vector. So resultant vector will be under root of p square plus q square plus 2pq cos theta. So that is f square plus 2f square cos 60 is nothing but 1 by 2. Root 2 will get cancelled. R is equals to under root of 3f square. R is equals to root 3 into f. Right. Root 3 into f. Now the resultant force acting on this body, okay, will be root 3 into F. F is nothing but gm square by a square. Right. See, if you take at any point, the same force will be acting. If you take here or here or here, at any body, the same force will be acting. This is nothing but case 1. Case 1. Now case 2, how will be asked? Case 2, apart this 3, fourth body will be introduced. Fourth particle will be introduced here. Now fourth particle, now case 2. Now case 1 I did. You try just case 2. Let us see. Case 2. Here are 3 bodies are there. 3 bodies. Masses. Here are 1 more mass is placed. What is the net force acting on this particle? Right? This is nothing but A. This is 60 degrees. This is also an equilateral triangle. So what I want? The net force acting on this body. First you copy down this one, then go for case 2, then after that we will discuss case 3. 3 points will be there for triangle. Same manner we will be going for 4 bodies concepts. Fine. So we are considering A, B, C are the 3 particles are placed at 3 corners of an equilateral triangle, and D is the body which is placed at the center of B and C exactly. Then we require to calculate the force acting on D. So here force acting between, gravitational force between D and B and D and C both are equal in magnitude but opposite in direction, they will get cancelled. So what is the remaining part? That is the gravitational force will be there from D to A. D to A, that is force from D to A. So we require the distance to calculate. So what is the distance from D to A? By Pythagoras theorem, or we can say it as by triangle, we can calculate, that is AD square is equals to A square minus, that is A square by 4. We will be getting 3A square by 4. AD is equal to root 3 by 2A. So now the force acting on A, that is the net force from D to A. So you can write it D to A. So D to A, it will be, so F dA, you can write it as F dA, right? So F dA can be written right here. So gm square by the distance is almost root 3 by 2A whole square. So we will be getting finally 4gm square by 3A square is the net force in that. So what is the concept we are using here? Concept of what? Equilateral triangle concept, and application of that is nothing but 2 forces. Both are equal in magnitude and opposite in direction between dB and DC. Both will get cancelled, and finally we are getting the result for that particular problem. This is case 2. Okay, now see here are 3 particles of masses m, 2m and 3m are there, placed at the sides of an equilateral triangle of side A, m, 2m and 3m. Now m is placed at the midpoint. So what is the net gravitational force acting on this one? To calculate, simple concept is here vector only. Definitely vector concept we have to use. Now between these two, one force, let us take that this is F. Right? These two are what? Again, let us make it, this is F1, F2, F3. First we have to calculate what is F1, F2, F3. For that sake we require this distance. How to calculate that distance? Right? Now if I just continue this one, this angle is what? 30 degrees. This distance will become A by 2. So I want this distance. Okay, let us make it as this is what? X. So this and this both will be same. At any point, this and this will be same. So X, A by 2. So what is this? This is adjacent side and what? Hypotenuse. So cos I can take it as. Now if I take cos 30 degrees equals to what I can write? Adjacent side is a by 2 by what? X. So cos 30 is how much? The root 3 by 2 equals to a by 2 into x, or x equals to just cross multiplication or 2a by root 3. Am I right? The same distance you got or difference?
I didn't calculate the distance.
Yeah, without calculating you cannot get right. So this distance now. So now 2a by root 3 is the distance. This distance. And this distance will be same. Is it clear? Cos 30. Cos 30 is adjacent side by what? Hypotenuse. A by 2 by x. A by 2 will get cancelled. Sorry. This 2 will get cancelled. So what we are getting here? A by root 3. A by root 3. X is equals to a by root 3. So here a by root 3. Okay. So this distance a by root 3, a by root 3. Now we will write f1, f2, f3, and we will make it as generalized one. So f1 equal to m into m square, g into m square by distance is how much? A by root 3. So a square by 3, that is nothing but into 3. Now this complete part I will write it as f for our convenience. Then what I can write? F1 is equals to 3 if I am getting. Now f2 equals to, here f2 is between 2m and what? M. So g into m square, that is 2m into m, 2m square, 2m square divided by a square into what? 3 this is. A square by a by root 3 distance, a square by 3. That means f2 equal to, I can write 6f, right? 6f. Similarly, I can write f3 will be 9f. So f3 will be 9f. f3 equals to 9f. So f1, f2, f3 we got it as. Now applying this 2 vector concept. Now see here, this is force 3F acting upward direction. Here these two are 6F and 9F. So now what is this angle? Can you tell me what is that angle? This angle. 120 degrees. This is 120 degrees. Now I can calculate the resultant for this between these two. What is the resultant? So cos 120 is how much? Minus 1 by 2. So that means now I will write it as resultants. Let us make it as this is f dash. F dash is equals to under root of 6 square, 6f square, that is 36 f square plus 81 f square plus 2 into 6 into 9. So 6 how much? 9 6 okay, 6 9 54 f. Okay, 54 into 2. So 2, that is 2 into 54 into f square, this is f square into minus 1 by 2. Am I right? Into minus 1 by 2. So 2 will get cancelled here. Now what I will be getting? F dash equals to under root of 36 plus 81, how much? 170. 81 plus 36, which is nothing but 7. This is nothing but 11. So 117 f square minus 54 f square. How much you will be getting here?
63.
63
F square.
So that is nothing but f dash is equals to under root of 63 f square. F dash is equals to under root of what? 63 f. Root of 63 f. Now these both are opposite in direction. Under root of 63 f. Both are opposite in direction. We can subtract both the things. If you subtract both the things, then f dash will be root of 63 f minus what? 3 f. So 64, we have any root for 8, nearly 8 we can take it as, nearby value if you take it as 8, then I will be getting the net force is nothing but 5F. So this is the answer for it, right? So this is if I am taking under root of what? 64 F nearly, then we will be getting what? 8F, 8 minus 3, both are opposite in direction, 8 minus 3 is how much? 5F. So the net force acting on it is how much? 5F. If M, 2M and 3M, all three are different. If all are same, the net force will be what? 0. So simple concept will be easy. Is it clear? Check again.
If you you have not done this before, please subscribe to Physics Stream's GRP. As exams are nearby, this will be very helpful to us.